Hello, gentlemen. Today we are going to talk about a type of procedure which help the operation managers to take a wise decision in determining the right cutting pattern to meet the customer's expectation with a minimum cutting loss. This is a collaborative assignment supervised by Dr. Layth Hadidi, and my team is Muhammad and Qasim and myself, Faisal. The outline of our presentation will be illustrated as the following. We'll start with the introduction, followed by the formulation of objective function, the algorithmic approach, also the illustrative example, and we will also give a formulation short video that will illustrate the example more, and we will conclude with the conclusion. For introduction, we want to elaborate what is cutting stock problem. So, cutting stock problem is the problem of cutting standard sized pieces of stock material. For example, paper rolls, the sheet metals, and even for the, wood, glass, etc. And they cut it into pieces with the specified sizes that the customer asks for, while minimizing the total wastes. There is so many types of cutting stock problem, which is depend on the dimensionality, and we will classify our types depending on that. So as you can see here, there is one type which is one-dimensional problem. The other industrial application occur when cutting pipes, cables, steels, and bars. About the two-dimensional problem, which is encountered in furnitures, clothing, glass production, but not many comes in three-dimensional application, which is involved in cutting in packing problem, and has many industrial applications such as packing the objects in shipping containers. As we all know, in all LB formulation problems, we need to find the objective function and the constraints. So suppose that we have a paper rolls, and it is required to determine the cutting patterns that minimize the total waste while satisfying the demand. As you can see here, this is the objective function shown in front of you with the constraints. And it is also worth to mention that this problem is a two-dimensional, and the graph on the right shows to you the width and the length of the problem. As you can see here, minimizing x0 gives you the surplus that remaining after cutting the paper rolls. And also it's shown here that WK is the width of the roll, LI is the length of the roll, MK number of cut patterns can be produced from kth roll, IJK is the number of units of WI being cut according to the jth pattern from kth roll. XJK is the length of the kth roll being cut according to the jth pattern, and the SJ is the surplus length being produced of roll with WI. This is the algorithmic approach for solving any cutting stock problem, and it's going to be illustrated more and efficiently with our friend Qasim in the short video. To illustrate how the algorithm works, let us consider the following example, which is done by Mr. Saad al-Sulaiman. As you can see here, this is just an illustration of how the product is going under the cutting process. This picture shows the raw product, which is like a roll, a big roll, and after that is going to the cutting machine till reaching the final customer demand, which is shown in the green, and the black ones are the cutted lost from the original product, raw product. The Aluminium Rolling Mill Company, Armco, received 4 orders for aluminum coils with the following specification. As you can see, starting from 50, 40, 30, and 20. This is for the width, and the length is 4,000, 5,000, 10,000, and 6,000. By applying algorithm to the previous example, as you can see here in this slide, this is one of the solution for the previous problem, and we have around 20 solutions, and it's going to be illustrated more in the next short video.
Assalamu alaikum. Today I would like to introduce you our example, and I would like to show you the method that we use to solve using the cutting stock profit. Here we have our example. There is we're using Aramco standard, which is usually with cutting width. They have two standards, 130 and 100. All right. This example, there is a customer that required 4 type of width. We start with 50, 40, 30, and 20, and we have length which is 4,000, 5,000, 1,000, and 600, 6,000. Right. I'm not interested in the length actually, and the width. Our objective is to minimize the cut losses. All right. Here actually, since we are using our in our example, we're using the standard width with 130 centimeters, and require the reduced roll, which is 50, 40, 30, 20. The required one. All right. So here with 130, we have 50. So how many 50s are in 50? How many width we can make? Two times 2 of the 50, 150, right? So 250, we have 100. 100, how minus 130, so minus 30. All right, so with 50, we make it 2. And with 40, we have how many losses? 0 multiplied by 30. All right, we have 0 minus 30, we have minus 30. And here, since we have 30, we can have 2 choice actually, with 1 multiplied by 30, okay, or 0 multiplied by 30, which is not having 30, or we have. So we have 30 multiplied by 30, we have the minus 0. Here is 30 minus 30. 0 minus 30, we have is 30. All right, and the same way with the 20. Here we have actually it will be 0 with 1. So we have here, so that will be 0 here, and with 30, and the remainder is actually 20 multiplied by 1 here. All right, 20 multiplied by 1, we have 20 minus the remainder is 10. So in the first column, actually, the cut losses is 0, right? In the second column, we have the cut losses is 10. All right, this is for the first column. So here we have the reminders. We can have 250, here is 150, and here 0. 50. All right. So here with 150, okay, minus 130, that will give us the minus 80. All right. Here the 80 with 40, we can have actually 2 of 40. Remainder. Okay. So we have the cut losses in this column is 0. Okay. So with 1 multiplied by 40 here, the remain minus 80, the remainder is 40. Okay. Here we have 0 multiplied by 40. 40 minus 80, so the remainder is 80. So here 40 with 30, we can say it's 30 multiplied by 30 multiplied by 1, or 30 multiplied by 0. So here 30 multiplied by 1 is 30 minus 40, the remainder is 10. And here is actually 20 with 10 is the losses, it's actually 10. And this Other row we have 0 minus 40, we have 40. Okay. With 20, say 20 multiply by 2 actually to get the minimize the cut losses, which is actually 40 minus 40 is 0. And it's actually the same with 80 here, since it's 80. So how many 30 we have gonna have? We're gonna have 3. And the rest of the solving the problem will be showing in the PowerPoint, but this is actually what we're showing you is how to solve it. And the rest of the problem I was solving the same way for each column with the brush. And even we're gonna use the standard of 100, is gonna use the same way of solving this problem.
This is the 20 solutions already explained, one column of it in the short video previously, which is already generated from the 130 centimeter width of the cutting roll. And here is the table result for all the 20 solutions. In conclusion, there are 4 important things that we need to mention that extra costs were saved to be used in order to reduce the wastage. A paper and sheet metal working industries need cutting stock problem to minimize the total waste. Also, cutting stock problem is for determining the cutting patterns. And finally, a cutting stock problem is one of the main classical problems in operations research that is modeled as LP problem.